Hi, now we are going to discuss another problem related to state reduction. So here, left side, that state diagram is given. So this is the important questions for the examination purpose of you. So in this state diagram will be given. For that given state diagram, now we have to reduce the number of states, and again we have to redraw the state diagram. So in this case, if you see that total how many states are given? Total we have five states are there. A, B, C, D, E. Total five states are there. So for that, we have a state table format. For that, we are writing the present state, next state. So for the next state, two condition is there. When input is x equal to 0 or when input is 1, then what will be the corresponding outputs? So that here right side we have output. For output also we have when input is 0, when input is 1, then what is the corresponding outputs? So we have five states A, B, C, D and E here. So corresponding states we have already written here in the state diagram. Now same thing we are going to represent in the state table. So in this state table, if you see that in our case, so first we are at the state 1. So now when we are at state 1, so that is state A represented by here A. And if you have some idea about the milli machine, so in the milli machine, this output depend upon the inputs. So whenever we have combinational circuit in between, again it is going to take the after the output of the flip-flops, again it's going to take the initial input. So this is the Mealy machine. This diagram, whatever is given a state diagram, that is given for the Mealy machine. So in the Mealy machine, whatever transformation you are seeing here, so in the numerator it is written input and in the denominator it is written output. So here when we are at state E, now if you see that when here input is 0, this input is 0, then what is the next state? Next state is B. So here for us, when input is 0, next state is what? B. And what is the corresponding output? This is the output. Output is what? 0. So that we are writing here 0. Similarly, when input, we are again at the state A, when input is 1, what is the corresponding output? 0. So when input is 1, it is going to change the state from A to D. So here we have to write D and corresponding output is what here? 0. Now we'll write for the another state. Suppose now we are at B. So from B, again, if you see that input is 0, it is going to move to the next state E. So from B, we are going E when input is 0 and corresponding output is also 0. And again, from the B, when input is 1, it's going to be the next state C. So next state is C and corresponding output is what here? 1. So in the same way, we need to complete the for all states. Now we are at C. So at C, when input is 0, again it is going to back to the self state. So that's the next state would be also here C. So what is the condition here? If input remains same. So from the C, yes. So at this condition, if you see that when input should be 0. So at C, when input is 0, so this is the input is 0 here. So we are moving to D. Okay. So here what we'll write? D. And corresponding output is what here? 0. So that we are writing here. Now here input is 1. We are at C, input is 1. So what is the next state? Next state is the self state. That's why we are writing here C. And corresponding output is what? 0. This is the corresponding output. Next, we are going to move to the another stage. Now we are going to, suppose we are at D. At D, if input is 0, if you see that here, input is 0, we are moving to B. At D, when input is 0, we are moving to B, and corresponding output is what? 0. This is the corresponding output. At D again, when input is 1, we are going to move in the self state. So that's why here we'll have D, and here output is what? 0. So that output we are writing as the 0. One more state is remaining. So that is the E. So when we are at E, if input is 0 here, we are going to move to the A. So next state is A. Corresponding output is what? Corresponding output is 1. So that 1 is written here. Now another, when we are at E, when input is 1, next state is what? C. So C will be written here. And corresponding output is what? 1. So this 1 should be written here. Now we have algorithm for this. When we'll say that two states are equivalent, for that algorithm is that two states are said to be equivalent if for each set of the combinations they have same next state as well as same output or equivalent, then it will be said to be the equivalent states. Then if two states are equivalent, then we'll write only one state will ignore. So that we have to find in this state table that which two states we can say it is the equivalent. So that we need to find in this case. So now if you'll observe that which having two next states same. So if you are observing here, so that if you'll see the A and D here, present state A and D, so both having same next state, BD, and here also BD. Now you see the corresponding output also should be same. So for x equal to 0, it also has 0, it also has 0. For x equal to 1, output is here also 0, here also 0. So that's why these two states, A and D, will said to be equivalent, and D will be replaced by A. Wherever we have this row completely, we are going to delete. This row we are not going to use, okay, in the next reduced table. Apart from this, wherever we are writing D, that D will be written by A. D will be replaced by A. Like here, if you see that here D is there, this D will be replaced by A. This D, it also will be replaced by A. And this D is also going to be replaced by E. So after drawing this table, you need to write few lines about this in the word, that how these two states are equivalent and we are going to replace D with A. So like this you need to write in the word. After that, next is the reducing table. But here we have seen that this table only will be the last reduced table. After that, further reduction is not possible. So its name is given here, reduced table. So next states, what are things are we have here? A, B, C, and D is not there. Since D and A is same, am I right? So that's why D we are not considering. So now what we are left remaining? We have B here and D is replaced by A. So we are writing A here. E is already there. Same thing we are copying from the first state table. Only D we are replacing by A, and the present state D, that row we are neglecting here. So now again here, this is the C. Again, if you see that here D is there, so this D will be replaced by A. Again, we have C. And finally, again, you have B. And again, this D, yes, this is not going to come here. So this row we are not seeing. Now we'll see here from the E. So here what we have? A. So this A should be written here. And here again what we have C. So that C is written. And similarly, same output value we are going to write, whatever output values are here. So this is the 0, 0. Again, we have 0, 1, 0, 0, and last one is the 1, 1. Same from this table, we have copied. Okay, except this one. As per the present state, we have written this. Now again in this present table, again we'll try to find equivalent states. So whether anyone having equivalent states. So now if you see that here C and E both having same next state, AC, AC, but their outputs are different. Here it has 0, 0 output and E having 1, 1 outputs. That's why these two states will not be said to be equivalent. So this is our final reduced table. Now from this reduced table, we need to draw the state diagram. Okay. So this reduced table we are going to use finally, and it's become our reduced table. So on the basis of that, now again we are going to see the next values. So now here you see that already I have written here so that it will take less time. So now finally we have how many states we have left with? 4. In initial diagram there was the 5. Now we are left with 4. So where was the original position? In the same way, we'll try to write the states here. We'll try to represent in the same way as per the initial given state diagram. So which state we have reduced here? D. So that D we are not going to write here. So first state is what here? A. Next we are going to take another is the B. Next is what? C. And here we have D. Sorry, here what we have E. D is not there now. Okay, now we have A, B, C, E only. So these are the taken here. Now I will see the from the state table. From the reduced state table, we need to draw the state diagram. So now here when input is 0. So what is the next state? B. So when we are moving from the A is the present state. So when input is 0, next state is what? B. So input is 0. And what is the corresponding output? Corresponding output is also 0. So that we are written here 0. Again, we'll try to move from the, so again, it's not completed. Again, another value is what? When X is 1. For that, next state is what? A itself. So we are in the self state. What is the condition here? Input is 1. So input is 1, corresponding output is what? 0. So that we have to write here 1, denominator 0. Now from B we are going to move to the next state. So this one, this row we are going to consider. So again, when input is 0, next state is what here? E. Okay. B next state is E. So we are moving to E. What is the input here? Input is 0 and corresponding output is what also? 0. So that here we are writing 0. In the numerator we are writing input. In the denominator we are writing output. Again here when input is 1, next state is C. So input is 1, next state is C. From B we are moving to C. Input is 1 and corresponding output you will see that that is also 1. So like this, now we'll move to the next state C. Now we are at C. When input is 0, what will be the next state? Next state is what? A. So this is the long arc we have to make from there C to A. So here input is 0. Corresponding output is also 0. Again, if you see that at C itself, if input is 1, this input is 1, then what is the next state? Is C. Means it is in the self state. So input is what here? 1. And corresponding output is what? 0. So that's why we are writing 0. Now we are left with one more table here. So that if you see that in this case, we are now at E. So at E, when input is 0, we are going to move to A. So from E, we need to connect the A. With the help of a straight line, we need to connect. It will look better. So input is what here? 0. Corresponding output is what? 1. So we'll write 0 and denominator is 1. Now again at E itself, if input is 1, output is what here? Next state is what? C. So again at E, we are at E. Now input is given. Input is given. Then we have to move here. Next state is C. So input is given here is 1. And what you are seeing that corresponding output is also 1 here. Like this, we are able to complete the state diagram. After that, if you want, means you can assign the state value also by using the binary assignments. You can use at last you want means you can write that reduced table with the help of state assignments. So in the state assignments here, if you see that now we are left with only 4 states. So to represent the 4 states, we require only 2 bits. So like A will be represented by 0, 0, and B will be represented by 0, 1, C will be represented by 1, 0, E will be represented by 1, 1. And wherever A is there, it will replace by 0, 0. Wherever B is there, 0, 1, C 1, 0, E with 1, 1. Like this, we have a state assignment also. If time is there in the exam, you can write that also. Otherwise, up to this is sufficient. So first of all, you need to write the state table from the given state diagram. Again, from the state table, we have to compare which 2 states are equivalent. So which one is equivalent, that will be replaced by another one. So like this process will be continue and we'll get the reduced table. From reduced table, again, we have to draw the state diagram. Thank you. Thank you very much. If anything is there to discuss, we can discuss.